Hello and welcome to this video that covers GCSE Mathematics, section 1 of multiples and factors. So here we're going to cover both topics, and the first thing we'll look at is multiples. Now multiples are very straightforward. They are exactly the same as times tables. So you could just think of these, when you say a multiple of 2, you are just talking about the 2 times table. So here multiples of 2, 2, 4, 6, 8, 10, 12, etc. When you talk about maybe multiples of 10, we are just talking about 10, 20, 30, 40, 50, etc. And these will go on for infinity. So essentially it's all the multiples of 2 from 0 to infinity, or 10 from 0 to infinity. And the most likely question in the exam would be something like this example here: list the first 5 multiples of 12. So all you do here is you just go through your 12 times table for the first 5 values. So here we've got 12, 24, 36, 48 and 60. That gives you the answer to this question. If we say another one, list the first 6 values, list the first 6 multiples of 7, we would say 7, 14, 21, 28, 35 and 42. So that's the first, second, third, fourth, fifth and sixth. And that's all you need to do for multiples. So multiples are just times tables, that's it. So when you see multiples of something, multiples of 12, multiples of 15, it's just the 12 times table, the 15 times table. Just watch out as well, this is the first 5 multiples. Obviously this is telling you how many you need, and this is telling you which times table you need. Okay, the second thing that we will look at today is factors. And factors are all the numbers that can divide into a given value and result in an integer. So in the example here, what we have is, if we're given 8 and we want to find the factors of 8, what we do, or one method of finding it, is to start with 1 and go from 1 to 8, dividing 8 by that number. So if we start off with, let's call it n, let's say 1, so we do 8 divided by n. So in this one it's going to be 8 divided by 1, which is just 1. Which is 8. So if it gives an integer value, if the result gives an integer value, it means that value is a factor. So if we do 2 instead, and we do 8 divided by 2, we get 4. So we know that is 1 a factor? Is n a factor? So if n equals 1, it gives 8, so it is a factor. If n equals 2, and 8 divided by 2 is 4, then that means it is a factor. But let's try 3. So if we do 8 divided by 3, we get this number 2.666 recurring, which means that n is not a factor, which means that 3 is not a factor. And as you can see here, 1 is a factor, 2 is a factor, and 3 is not a factor, and 4 is a factor. So as long as this result here is a whole number, is an integer, then we take that number as a factor. However, we could continue on and do 5, 6, 7, and 8, but we don't need to do that. We already knew that 4 was a factor, because if you look here at this result here, 8 divided by 2 equals 4, we already got a result of 4, which means that the number, we know that 4 is a factor anyway, because the result here on this section here, if it's a whole number, it also means it is a factor. And you can see this with 8 divided by 2. 8 divided by 2 is 4, so we said that 2 was a factor. But when we did 8 divided by 4 here, we got 2 as an answer, which we know was already a factor. So when we divide by 2, we get a result of 4. That means we knew 4 was already a factor of 8. Therefore, we can quickly find the factors of a number by using the results of dividing by 1, 2, etc. So if we look at our example and we rephrased it, what that means is that 1 is a factor, because 8 divided by 1 gives an integer, but also 8 is a factor. So 8 is also a factor. In this one, we've got 2. So 2 is a factor, so we know that one already, because that gives an integer. And then our result here is 4. So therefore, 4 is also a factor. We know that 3 doesn't work, so we can ignore that one. And then we get to 4, but we've already know that that is a factor anyway. So whenever you get to a value that you are repeating, so whenever you are dividing by a factor that you have already found, so we have already found 4 here, so therefore we don't need to continue any further. We found all our factors. So all our factors here are 1, 2, 4, and 8. And there we go, 1, 2, 4, and 8. And this explains the shortcut a little bit more. So another shortcut for finding all the factors is to stop when you're repeating a number. So for example, let's find all the factors of 12. So first of all, we do 12 divided by 1, because we want to see if 1 is a factor, and we get an answer of 12. So therefore, we know that 1 and 12 are factors. Let's try 2. So 2, so we do 12 divided by 2, which is 6. So therefore, 2 and 6 are factors. 3, so we do 12 divided by 3 is 4. So we know 3 and 4 are factors. Now at this point here, our next value is 4, but we already know that 4 is already a factor because we just found it in the previous one. So we don't need to do it. We can stop. So once you reach the number where you've already found a factor, you can completely stop. You don't need to find any more of the factors because you found them all. So the answer to this would be 1, 2, 3, 4, 6, and 12 are all factors of 12. And we can see if you go through, so obviously 12 divided by 4 is 3, so that means 3 and 4, which we already know. And then 12 divided by 5 is not a whole number. 12 divided by 5 gives a result of 2.4. So we know 5 is not. 12 divided by 6 is 2, so we know that 2 and 6 are, but we already knew that. 12 divided by 7 is 1.71, so we know that 7 is not a factor. 12 divided by 8 is 1.5, so we know that 8 is not a factor. 12 divided by 9 is 1.33, so we know 9 is not a factor. 12 divided by 10 is 1.2, so we know that 10 is not a factor. 12 divided by 11 is 1.09, so we know that 11 is not a factor. And 12 divided by 12 is equal to 1, so we know that 1 and 12 are factors. Now, we've gone from 1 to 12, and you can see we haven't found any new factors. We found that 1 and 12, 2 and 6, and 3 and 4, but we'd already found those results. So you can see that once you reach a number that you have already found as a factor, you can stop, as proved by this example. So that is all for factors. So that is all you need to know. So let's try some examples. So if you can, pause the video and see if you can give these a go. Otherwise, I will go through them. Okay, hopefully you paused the video and had a go at these. So let's have a look. The first question then is find the first 8 multiples of 9. So if we remember, we are using this value as our times table, and this is the number of values. So here we go. We've got 9, 18, 27, 36, 45, 54, 63, and 72. So that's 1, 2, 3, 4, 5, 6, 7, 8. So they're the first 8 multiples of 9. So essentially it's up to the 8 times 9. So we do 1 times 9, 2 times 9, etc., 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 up until 8 times 9. The second one is find the multiples of 3 between 11 and 19. So this one is a little bit of a different question because we have got a range that we are focusing in. We only care about what happens between 11 and 19. So if we start from 1, we know that 3, 6 and 9 will not be part of our answer because they are less than 11. And then we go through, our next value is 12, which is correct. So 12 is between 11 and 19. Then we've got 15, which is also fine. We've got 18, and then our next value is 21, which is outside the range. So our answer in this case is simply going to be 12, 15, 18. It's looking for the 3 times tables, so find the multiples of 3 between a particular range. So we just look at any of the values that can be divided by 3, always in our 3 times table. And that is it for question 2. Number 3 is find the factors of 27. So to find the factors of 27, what we do is we just go through and divide 27 by all the numbers from 1 to 27 until we hit a repeated number, and we use the integer results as our answer. So our first one is 27 divided by 1, which is equal to 27. So therefore our factors 1 and 27 are factors. 27 divided by 2 is equal to 13.5, so that means 2 is not a factor. We do 27 divided by 3, that is equal to 9, so 3 and 9 are factors. 27 divided by 4 is equal to 6.75, so 4 is not a factor. 27 divided by 5 is equal to 5.4, so 5 is not a factor. 27 divided by 6 is equal to 4.5, so 6 is not a factor. 27 divided by 7 is equal to 3.86, so 7 is not a factor. 27 divided by 8 is equal to 3.375, so 8 is not a factor. And now if we do 27 by 9, we already know the result is 3 because we did it earlier on. And this is our first repeated value. So we know now that we found all our factors because we reached a repeat. So our factors for 27 are going to be 1, 3, 9 and 27. And that is our result for question number 3. The next answer is to find the factors of 100. So to find the factors of 100, all we need to do is do exactly the same again. So we say that we've got 100 divided by 1 is equal to 100, so 1 and 100 are factors. We've got 100 divided by 2, which is 50, so 2 and 50 are factors. 100 divided by 3 is going to equal 33.33, so that means that 3 is not a factor. 100 divided by 4 is 25, so that means 4 and 25 are factors. 100 divided by 5 is equal to 20, so we know that 5 and 20 are factors. 100 divided by 6 is equal to 16.67, so we know that 6 is not a factor. 100 divided by 7 is equal to 14.29, so 7 is not a factor. 100 divided by 8 is equal to 12.5, so 8 is not a factor. 100 divided by 9 is equal to 11.11, so 9 is not a factor. And 100 divided by 10 is equal to 10, so 10 is a factor. And we can stop here because we've got a value which is 10 and our result is 10. So this is essentially the same as a repeated value as well. So we can say we can stop completely now because we have a repeated factor. So we found all our factors for 100, so now it's time just to gather them together and put them as our answer. So we have 1, 2, 4, 5, 10, 20, 25, 50, and 100. And that is our answer for 4. So there's quite a lot of factors in there for 100. And the last question is find the factors of 3, and do you know what this number is called? So here, if we do 3 divided by 1, we get 3. So we've got 1 and 3 as a factor. 3 divided by 2 is equal to 1.5, so 2 is not a factor. And then 3 divided by 3, well, we've already done this one because 3 is equal to 3 divided by 3 is 1, which is found, and we've already found 3 as a result here. So we just get a pair of repeated roots. So therefore, our factors of 3 is just going to be 1 and 3. Now, you may have done this before and you may have not done this before, but this is what's called a prime number, which is what we will cover in the next class. And a prime number is essentially a number that has 1 and itself as a factor. So for 3, it's just going to be 1, which is everything is divided by 1, and 3, which is the value itself. And it only has those as a factor, therefore we call it a prime number. Okay, that is it for today. If you just wanted to confirm the answers are here. So we can see we've got exactly the same as what's expected. If you do have any questions, please let me know. Otherwise, thank you for listening.